Hi, students. How are you? I'm fine. I'm your tutor for this course. My name is Amir Waleed, and I'll be teaching you this course, which is Cambridge O levels IGCSEs, right? And in this course, the code is 0625, and we will be studying about this course. And let's see how the things are. Okay. The syllabus is being shared with you. So basically, what we are going to do in this, we will start with the first chapter. So our chapter is based on basically mechanics. It's a section, mechanics, right? In mechanics, technically speaking, we will be doing what exactly we will be doing. Our first portion will be kinematics, right? Now, kinematics will be what? What it involves, first of all, it involves basically different things in this. Okay. It involves basic phenomena. What is motion, rest? These are the things basically which involves in it. The question arises, what is basically mechanics and why do we divide it into kinematics and dynamics? There are two portions of it, right? So let's talk about kinematics. Remember that when you talk about kinematics, it means the study of body in motion. When the body is in motion, you study certain physical quantities related to the motion, like you study about the speed of the body, or you can say velocity of a body, how much distance a body is covering, or you can say displacement a body is covering, right? Then if a body has increasing the speed or velocity, what will be the acceleration of that, right? So under kinematics, we will study about all these quantities, and then we have certain formulas to find out these physical quantities. So calculations are also part of this section, calculation related to all these quantities, right? Now, another very important thing is that in kinematics, there are two type of graphs we have it. Kinematic, we call them kinematics graph. One graph is called as distance time graph, and the other one is called as a speed time. Now, these are the graphs which are used to actually define a certain motion, right? And we will be discussing some very basic things about how the car or anything can be moved or covering the distance, and how to find out the same above quantities by using small calculation are also being involved in these. So distance time graph and speed time graph, how the quantities above quantities, like from distance time graph, how to find out what is the total distance covered, how to find out the speed of a car or speed of an object. Same thing for speed time graph. How will we know that what is the state of a car at the moment? So these are the things we will going to study. So let's start. Let's start with the start. So in kinematics, what we are going to study, we are going to study while the body is moving, what are the things associated. Now, question arises when the body is moving, it means at that point of time, we need to explain two quantities or two definitions which are very, very important. One is called as rest and the other one is called as motion, right? What are these? Now, this is very, very important. When you talk about the rest, it means generally a body is in the form, in the state of a stationary mode, right? But how to explain that? Resistance, I mean, in case of rest, we can say that if the body is not changing the position in a given time, right? And in motion, in case of motion, if the body is changing its position in given time. But still, there is something which is missing in these two definitions. Now, for that, I want to give you an example for this. All right. Now, what are the examples and how do we actually define it? Very interesting example is, let's suppose you have a car, all right, and a person, anybody, is standing here. That guy is taking the car, driving a car. When he sees the person driving a car, right, then you can say that the state of a person sitting in the car is in motion. Why? Because car is moving. So that guy is moving. So the state is motion. But the same guy once sit inside the car and now he sees the same person. He's sitting on the steering seat, the driving seat, and he's just driving a car, right? For that, now a person is on his seat resting. So the person is in the state of rest. Now, what did I do? I simply changed the position of that gentleman. Now, remember one more thing, anything which is under consideration is called a system. Other than that, everything is called as surroundings. So technically, what is exactly happening? I just changed the position of the surrounding. So the definition, or you can say state of a person is changed, right? So basically, one thing you need to add, this is very, very important, which you students, you need to understand that you can't just say that a person is changing its position. It should be added with that with respect to surrounding. Same thing on the other side as well. With respect to surrounding. Surrounding is very, very important. I'll give you another example. For example, if I am standing here on the road, if some person sees me, my state is rest. But if somebody sees me from the moon, because Earth is moving, so he will say that I am in this state of motion. So basically, they are like interrelated definitions for both rest and motion. You can't just say a body is in the state of motion or rest. You need to see according to which surrounding you're talking about. Okay. You can't just say body is in the state of rest, because if surrounding changes, maybe the state of rest change into state of motion, right? So this is the basic definition of rest in motion. Now let's start with the physical quantities related to the body in motion. The first thing is the physical quantity is called distance and displacement. Now, what is the major difference between distance and displacement? These are 2 points, right? A and B. If I call a distance, what does it mean? It means that you can have any type of distance, you can have any type of route between A and B. If a person has to come from A to B, he can select any way he wants. It can be a circular way. It can be a straight route like that with different, not exactly the straight route. It can be a very much straight route. Any route he can select or she can select. So basically, I can say measure of any route between point A and B is called distance. And what is displacement? When I say displacement, right, remember that displacement means the shortest distance between the 2 points. The shortest distance between the 2 points. When I say shortest distance between 2 points, it will always be in the straight line, right? So a distance in a straight line between A and B is called as displacement, or you can say a distance with the direction is called displacement. So what is the major difference between distance and displacement is that in distance, the important thing is the initial and the final destinations. You can take any route of your choice. Value or magnitude is important, but direction is not important. You can take any direction. It can be anything. But displacement is a particular direction displacement. Displacement is a particular direction distance. Like if a person is just going from A to B, that's fine. But if I ask anyone, you need to go in the north direction from A to B. Now I mention a direction, it means now it's a displacement. That is the reason distance is a scalar quantity. Which means a physical quantity which can be specified with the magnitude only. Right? And what about displacement? Displacement means, first of all, displacement is a vector quantity. What does it mean? It's a physical quantity which can be specified with magnitude and direction. So any particular quantity in which magnitude and directions are important, we call them a vector quantity, right? Now, what are the SI units for both of them? Standard International Unit. SI unit is basically meters. There can be other units as well, like kilometers, miles, so many things, but SI unit is meters, right? So these are the two quantities we just discussed. Now, next two quantities are speed and velocity. What is speed, first of all? Speed has a simple definition: distance covered by a body in a given time. Now, what does it mean? Let's suppose you have a car here and it is covering a distance. The formula is speed is equal to distance covered divided by time. The SI unit will be meters per seconds. Now, let's talk about it. Let's suppose this car is traveling. In 1 second, it covers a distance of 2 meters, let's suppose. So the distance will be, the speed will be 2 meters per second, right? So distance covered by the body in given time is called as speed. And the SI unit is meter per second. Now the next thing is velocity. Now velocity and speed, as far as basic definition is concerned, both are same. But the only major difference is it's a displacement covered by a body in given time. Or if you do not understand it properly, then you can say distance covered by a body in given time and in particular direction. So basically here again, as previously, displacement has a direction. So here velocity has a direction. So if any person is traveling 2 meters with the speed of 2 meters per second in a north direction, it means it's not a speed with which he or she is traveling, but rather it's a velocity. Okay. The unit is also same for the velocity as well. It's the same meters per second. Right. Now, another very important point at this point is, let's suppose you have this car here. And let's suppose this car is traveling for 5 seconds. In each second, the car is traveling 2 meters. Let's suppose it's a supercar and it is traveling a same distance of 2 meters in just 1 second. By the way, practically it's not possible, but let's take it as an example. So for the first second, the speed will be 2 meters per second. For the second, the speed will be 2 meters per second. And for the next one, it will be 2 meters per second and 2 meters per second. So technically speaking, the body is covering an equal distance in equal interval of time. So if the body is covering equal distance in equal interval of time, the speed will be constant, or body is moving with uniform speed. So it's called uniform speed. Now, student, at this point, you need to understand one thing. You can interchangeably use velocity and speed. Same thing, distance and displacement, until specifically the direction is being mentioned. Otherwise, as far as magnitude is concerned, both are same. All right. So if a body is moving with a constant speed, we have a formula there that relates speed, distance, and time, which says S is equal to Vt, where S is the distance, or as I said, interchangeably, it can be displacement, that can be velocity or speed, and that can be time. So distance is equal to velocity into time. How can you use it? For that, I have got one questionnaire for you. Small question. Check it out. If a plane is typically average speeds to around 250, consider it as a constant speed, 250 meters per second. They're saying calculating the distance by the plane moving at an average speed of 2 hours. Remember that the speed is given in seconds, meter per second. So you need to convert that time into seconds as well. So if this is your speed, which is v here, you need to find the s, which is a distance here. Time is given as 2 hours. So you have to convert it into seconds, which is 2 multiply by 60 and multiply by 60, which is equal to 7,200 seconds. So use the formula S is equal to Vt, or average speed is equal to distance travel upon time. It's the same thing, right? So velocity or speed is 250 multiplied by 7,200, which is actually equal to the distance travel, which is 1800 and then 3 zeros meters. So this is the distance the body just covered. So we will be finding, we can easily find out the distance if a body is moving with the constant speed. And in that case, the formula can be distance is equal to velocity, or you can say speed into time. But remember that all the units should be in SI units. Distance should be in meters, speed should be in meter per second, and time should be in seconds as well. Okay. So my students, we will finish this small lecture, which is related to the very basic rest motion concept, and then distance displacement concept, and speed and velocity concept, and also uniform speed as well. Okay. In the next lessons, we will continue further. For that, keep watching my videos. Okay. Thank you. Bye. And see you in the next video.